Alright, so here is the video for the quiz review for this unit. It's over targets 1 through 7. So I'm going to start with the target 1 stuff, which is simplifying radicals, including imaginary values and stuff like that. So number 1, I have a negative square root of 18. I'm just going to go ahead and start by breaking down 18. I have no numbers out front, no negatives on the inside, so I can just go ahead and start this. 18 is 2 times 9. 2 is a prime number. I'm going to box it, and then 9 is 3 times 3. I can break that down. 3 and 3 are both prime, so I'm going to box those up. So now I have the negative square root of 2 times 3 times 3. And what I'm going to do in red is circle all the pairs that I have. And so I'm going to pull out 1, 3. That 3 is going to go right out front with that negative sign. And I have 2 left over on the inside. So I have the negative 3 square root 2 as my answer. What I did was that with that 3 was I just brought it right out to the front and multiplied it by that negative 1 that's kind of hidden there. It's just a negative sign, but technically that is a negative 1. So that's what I did with that 3. For number 2, I have a negative 4 times the square root of negative 12, and I do have a negative under the square root, so I'm going to divide that up into 2 parts. So I'm going to have that negative 4 still, but then negative 12, the square root of negative 12, can be broken down into the square root of negative 1 times the square root of positive 12. Now the reason I did that was because root negative 1 is I, so this becomes negative 4I. And then the square root of 12 I'm going to break down like normal. So 12 can be broken down into 3 times 4. 3 is prime, I'm going to box it. And then 4 can be broken down into 2 times 2. I'm going to box those as well. So now I have negative 4I root 3 times 2 times 2. And again in red, I'm going to circle my pairs. So I have a pair of 2's, which means I'm pulling out 1, 2. And it's going to go right out front, being multiplied by that negative 4I. Now when I multiply it out front, negative 4I times 2 just becomes negative 8I. And then I still have that root 3 left over. So negative I root 3 is the answer for number 2. For number 3, negative square root of 12. Very similar to the first one and the second one. I have no negatives under the square root, so I'm just going to start by breaking this down. I'm going to do 4 times 3 this time. And then 4 is 2 times 2. Now I have all these primes that I can box up. And I now have negative root 2 times 2 times 3. I'm just writing out all the boxed numbers that I had. In red, I'm going to circle all my pairs. So I'm pulling out 1, 2, putting it right out front with that negative sign. So now I have negative 2 square root 3 left over. When I pull out that pair, it goes away under the square root, and one of those numbers comes out front. And then number 4, 3 root negative 45. So just like in number 2, I'm going to break that negative 45 up into negative 1 times positive 45. So I have 3 times root negative 1 times root 45. And then square root of negative 1 is I. So this becomes 3I root 45. And then I can break this up like normal. I'm going to say 45 is 3 times 15. And you could do 9 times 5. You could do whatever. 15 is 3 times 5. And then those are all prime numbers. I'm just going to box all those. Alright, so now I have 3I root 3 times 3 times 5. And then in red, I'm going to circle my pairs, which means I'm pulling out 1, 3, and I'm bringing it out front. Now, if for some reason I had circled 2 pairs, then I would pull out not 1, 3, but 2 3s. Or if I circled a pair of 3s and a pair of 5s, I would take out a 3 and a 5. So I'm taking out one number per pair that represents that pair. So this becomes 9I root 5. And that is my answer. Whenever you have a negative under the square root, you're always going to end up with an I in your answer. Alright, target 2 stuff. I can use the square root method to solve a quadratic. So my goal here is to get the variable that's being squared, so in this case m squared, all by itself. To do that, all I'm going to do is divide by 36 here. And that gets rid of it on the left. I'm left with m squared equals 16 over 36. Now in a different color, I'm going to go ahead and solve for m now, which is what I was trying to do from the very beginning, but I had to first get that m squared by itself. So now I'm just going to get m by itself. And to undo a square, I'm going to take the square root. So I'm taking the square root of both sides here. This cancels that out. And I am left with m on the left side, but then on the right, I'm left with the square root of 16 over 36. Now, what you can do when you're taking the square root of a fraction like that is you can just take the square root of the top and the square root of the bottom. That's essentially what I was saying right here. These are the same thing, just written differently. And now it makes more sense because 16 is a perfect square and so is 36. So I get m equals the plus or minus version of 4 over 6, because the square root of 16 is 4 and the square root of 36 is 6. So I can actually reduce that down a little bit farther. 4 over 6 is just 2 over 3. So I get m equals the plus or minus version of 2 over 3. All right, perfect. And then for number 6, n squared minus 2 equals 94. To get that n squared by itself, I'm going to add 2 to both sides to start, and I get n squared equals 96. Now I'm going to go ahead and undo that squaring by taking the square root of both sides. So this and this cancel. I'm just left with n on the left side. But then I have to go ahead and break down root 96 using my target 1 skills. So 96 divided by 2 is 48. So 2 and 48. And then 48 is 4 times 12, or 2 times 24. You can do whatever you want. 4 is then 2 times 2, and then 12 is 4 times 3, and then 4 is 2 times 2. So I have all these boxed numbers now, and you could have done that little branch tree thing in any order that you wanted. Like I said, you could have done 96 divided by 12, you could have done 96 divided by 8, whatever. I just picked 2 and 48 to start with. All right, so now using my target 1 skills, I now have n equals, oh, that was a weird n. I now have n equals the square root of all those boxed numbers. So 2 times 2 times 2 times 2 times 2 times 3. Right, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5 2s, and then 1, 3. In red, I'm going to go ahead and circle all my pairs. I only have 2 pairs, which means I'm taking out 2 2s. So I have n equals the plus or minus version of 4 root 6. Now, I got 4 because I took out my 2s, put them both out front, and multiplied them together. And then I got 6 because I was left with 2 times 3, which is 6. So here's my answer. Do not forget when you're solving for a variable using, or solving for a variable in a quadratic, we're always going to have a plus or minus version in our answer. So like number 5 was plus or minus 2 over 3, and then number 6 was plus or minus 4 root 6. All right, next page, number 7, still square root method. So I'm going ahead and subtract 1 from both sides to get r squared by itself. I'm left with 44. And then, like I've been doing, I'm going to take the square root of both sides. And I'm left with r equals root 44. Root 44 I'm going to do up here. So I'm running out of room. So 44 is 4 times 11. And then 4 is 2 times 2. So now I can come back and say that root 44 is actually 2 times 2 times 11. And then in red, I'm going to circle my pairs, which means I'm pulling out 1, 2, bringing it to the front. And I get r equals plus or minus, don't forget that, 2 root 11. All right, and then number 8. To get x squared by itself, I'm going to divide by 25. So I get x squared equals 81 over 25. Then I'm going to square root both sides, just like I was doing. And it's kind of like number 5, where I'm left with a fraction in the square root, but that's okay. because it's just going to be treated the same. I'm just going to take the square root of 81 and then the square root of 25. So I'm left with, oops, change colors here. I'm left with x, but then on the right, I get 9 over 5. And then don't forget that plus or minus, because I just took the square root of 81 over the square root of 25. These are the same thing, just written differently. So here's my answer for that one. All right, target 3, I can evaluate the discriminant and determine the meaning. So don't forget the discriminant formula, b squared minus 4ac. And then I'm going to go ahead and identify my a, b, and c values starting off. A here is 6, b is 10, and c is 7. Don't forget that a value is just that first coefficient in front of the x squared. My b value is that second coefficient in front of the x term. And then my c value is that constant at the very end. And also, if it was a minus 10, for example, in the quadratic, it would be a negative 10 would be my b value. So b squared minus 4ac, b squared would be 10 squared in this case, minus 4 times 6 times 7. I'm just using those values from here in this formula. So 100 minus 4 times 6 times 7 is 168, which gives me a negative 68 for my answer, which means I have 2 imaginary solutions. And then number 10, my A is 9, my B is 9, and my C is 2. So B squared minus 4AC, 9 squared minus 4 times 9 times 2. So 81 minus 4 times 9 times 2 gives me 72. So 81 minus 72 gives me 9, which is a positive number, which means I have 2 real solutions. And then number 11, my A is negative 1, my B is 6, and my C is 7. So B squared minus 4AC, I get 36 plus 28. 4 times a negative 1 times a 7 gives me negative 28. So essentially I had 36 minus a negative 28. So I ended up adding them together. So 36 plus 28 gives me 64, which is a positive number, which means I have 2 real solutions. And number 12. My A is negative 1, my B is 4, and my C is negative 4. So B squared minus 4AC, I get 4 squared minus 4 times A times C. So I get 16 minus 4 times negative 1 times negative 4 will give me a positive 16. So 16 minus 16 gives me 0, which means I have 1 real solution. And don't forget, what this is telling us is basically when I have 2 imaginary solutions, that means that on a graph, my parabola will never touch the x-axis. It will never hit it. It's going to be floating either up there or possibly down here somewhere. So if I were to graph that parabola or that quadratic, it would never hit. For number 10, 2 real solutions means it actually does cross through the x-axis twice, either like that or it could come down like this. When I have 2 real solutions, again, I'm crossing twice, I'm crossing twice, this way potentially. And then if I have 1 real solution, that means that my parabola hits the x-axis once and then bounces back up. So the vertex is actually on the x-axis. It could look like this or like this. That's what these answers are telling me, basically. It also means that when I actually solve using any method, I'm going to get either 2 real solutions or 1 real solution or 2 imaginary solutions. All right, target 4. Oops. Says I can use the quadratic formula to solve a quadratic, including imaginary/complex solutions. So the quadratic formula forces me to actually pull out my a, b, and c value, and then it also uses the discriminant in that formula. So I'm gonna do that first, just so I can kind of figure out how many solutions I'm gonna have and like what type they are. So don't forget that quadratic formula. I'll write it here in orange. X equals negative b plus or minus the square root of b squared minus 4ac all over 2 times a, or 2a. In this case, I'm going to write kind of off to the side here. My a value is 2, my b value is 11, and then my c value is 12. I'm going to plug those in to the discriminant first to see exactly how many and what type of solutions I'm going to have. So b squared minus 4ac would be 11 squared minus 4 times 2 times 12. And that actually gets me, let's see, 11 squared is 121 minus 4 times 2 times 12. That gives me 25. So I know I'm going to have 2 real solutions. Let's go ahead and do the quadratic formula now. X equals negative b, so negative 11, plus or minus the square root of my discriminant, which is 25, all over 2 times a, which is 4. Now, the square root of 25 is actually just 5, so this is going to work out really nicely. This means negative 11 plus or minus 5 all over 4. And I can actually do that math. If I'm left with a number that looks like that, with no radicals, no imaginary values, I can actually follow through with that and do negative 11 plus 5 over 4, and then negative 11 minus 5 over 4. Negative 11 plus 5 gives me negative 6. So negative 6 over 4 reduces to negative 3 over 2. And then negative 11 minus 5 is negative 16 over 4, which reduces to negative 4. So here's my 2 answers. Negative 3 over 2 and then negative 4. And I did actually get 2 real solutions, which is what I was trying to get in the beginning. So check. All right. Number 14. My a value is 3. My b value is negative 10, and my c value is 11. So b squared would be negative 10 squared minus 4 times 3 times 11. And let's see what that gets me. When I square a negative, I'm always going to get a positive, so that's 100 minus 4 times 3 times 11. That gives me negative 32 altogether. All right, which means I'm going to have 2 imaginary solutions. Okay, so let's plug that into the quadratic formula. X equals negative b, so negative 10 will give me a positive 10, plus or minus the square root of my discriminant, which was negative 32, all over 2 times a, which gives me 6. Now off to this side, I'm actually going to go ahead and simplify negative 32 under the square root. I know I have to pull out an I because I had that negative under the square root, and then I'm going to go ahead and start breaking down 32. That's 2 times 16, and then 16 is 2 times 8, 8 is 2 times 4, and 4 is 2 times 2. So this becomes I root 2 times 2 times 2 times 2 times 2. 1, 2, 3, 4, 5. Perfect. In red, I'm going to circle all my pairs. I have 2 pairs here, actually, so I'm going to pull out not 1, but 2 2s. Bring them out front, and this becomes 4i root 2. So I finally simplified it. I can bring it back up to my formula. and I have x equals 10 plus or minus 4i root 2 all over 6. Now, what I notice here is that 10, 4, and 6 can all be reduced a little bit further. I can divide all those numbers by 2, and I'm going to do that. So this becomes 5, that becomes 2, and this becomes 3. So my entire answer is actually 5 plus or minus 2i root 2 all over 3. Now notice I did not touch this square root of 2 when I was simplifying in my last step. You're only going to worry about those 3 numbers that I X'd out in black there. You're never going to touch that root anything when you're simplifying at the end. And that's my final answer because I have 2 imaginary solutions, so I can actually just put a little check mark. Check. I get the plus or minus version of that. All right, let's do number 15. 5v squared minus 125. Using the quadratic formula still, so I'm going to go ahead and say that my a value is 5. Try this again. My a value is 5. I don't have a b value in this case, so it's actually just going to be 0. And then my c value is negative 125. Okay, so b squared minus 4ac, 0 squared, minus 4 times 5 times negative 125. It's going to be a big number. So 4 times 5 times negative 125 is negative 2500. But if I do 0 minus that, it's actually going to be a positive 2500. Okay. So plugging this into my, so basically this means I have 2 real solutions. And now my quadratic formula. X equals negative b, or just 0, plus or minus the square root of b squared minus 4ac, which is 2500, I just found out, all over 2a, which is 10. And then off to the side here, I'm going to actually simplify 2500. When I divide 2500 by 5, I get 500. 5 times 100. I'll do 25 and 2, and then 5 and 5. So I have all these to box up. And then let's see. This becomes 5 times 5 times 5 times 5 times 2 under the square root. So I can pull out not 1 5, but 2 5s. They're going to go right out front. Oops, not 10. 5 times 5 is 25. And then I still have that loner 2 in the inside. So I can bring that back up here. And this becomes plus or minus 25 root 2 all over 10. Now I can reduce 25 and 10. I can divide those both by 5. So this is actually going to become plus or minus 5 root 2 all over 2. And that's my answer. I got 2 real solutions, no imaginaries. Okay, kind of draw like a little line to separate myself. Starting off with my discriminant again. So I have a equals 4, b equals 6, and c equals negative 108. B squared minus 4ac. So 36 minus 4 times 4 times 108. Oh, goodness. So I have negative 1728. And 36 plus 1728, because I have a double negative there, becomes 1764. Alright, so that is a big discriminant. I have 2 real solutions. And let's plug that into the formula. So x equals negative b, which is negative 6, plus or minus the square root of my discriminant, so 1764, all over 2a, which is 8. And then off to this side over here, I'm going to simplify 1764. I'm first going to divide it by, oh goodness, 36 and 49. That was easy. Totally guessed. 36 is 6 times 6, 49 is 7 times 7, and 6 is 3 times 2. So I have all these two boxed up. When I write my new radical with all of those boxed numbers in it, I'm actually going to put the 3's together and the 2's together so it's easier for me to see what I'm going to take out. So 3 times 3 times 2 times 2 times 7 times 7. A lot of pairs to work with here. I'm going to pull out a 3 and a 2 and a 7. I put them all out front and I have nothing left over. 3 times 2 times 7 is 42. And I have nothing left in the square root, which means that 1764 was actually a perfect square. 42 times 42 gives you 1764. You could have done that right off the bat, or you could follow the steps that like I just did, and it'll work out either way if you do it correctly. So negative 6 plus or minus 42 all over 8. And I can actually follow through and do that math. So negative 6 plus 42 over 8. Negative 6 plus 42 is 36 divided by 8. And if I divide 36 by 4, I'll get 9. And if I divide 8 by 4, I'll get 2. So 9 over 2 is one of my answers. And then negative 6 minus 42 all over 8. That becomes negative 48 all over 8. And 48 divided by 8 gives me 6. So my other answer is negative 6. And I got 2 real solutions, which is what I wanted. So I'm in good shape. Okay, target 5, I can use completing the square to solve a quadratic, including imaginary and complex solutions. Alright, so completing the square. In number 17, my first step is already done for me. It's kind of nice. I have that negative 3 off to the side already. So what I'm going to do is just kind of give myself some space here. I'm going to rewrite this in a little bit easier way. K squared minus 4k, leave some space, equals negative 3, and I need space over there as well. So now I take my b value, which is negative 4, and I divide it by 2. That gives me negative 2. Then I square it to give me 4, and that's what I'm adding here and here. So now my new thing is k squared minus 4k plus 4, and then I have negative 3 plus 4 on the right. My left side is actually going to turn in to a binomial squared, and my right side is just going to be 1, negative 3 plus 4. Now, what I'm going to do is take what I got in the parentheses here, and that's what goes in the binomial squared. So I always have my variable, in this case it was k, and then I take that minus 2 or negative 2 and I stick it right there. If it was a positive number that I got, I would put plus whatever number. But since it was a negative, I'm saying minus 2. And then from here, this is where I just do my normal solving and I take the square root of both sides. So this will cancel that out, and I get k minus 2 equals positive or negative 1. I have to take the plus or minus version, and don't overthink it. The square root of 1 is just 1. Then I'm going to add 2 to both sides, and I get k equals plus or minus 1 plus 2. And don't stop there, I can actually do that math. So positive 1 plus 2 gives me 3, and then negative 1 plus 2 gives me 1. Those are my two answers. All right, keep it going. Number 18, I'm going to add 77 over to the right to start off, and I get n squared plus 10, and leave myself some space, equals 75 actually now. Leave myself some space. Negative 2 plus 77 gave me 75. Now I'm going to take my b value, which is 10 divided by 2, and square that number. So now this is what goes here and here. I add it to both sides. All right, my left side is going to turn into a binomial squared, and then my right side is going to be 100, actually. 75 plus 25. Don't forget, whatever's in that parentheses is going to go right there. So in this case, it's a positive 5, so I'm going to say n plus 5. Now using my normal solving skills, I'm taking the square root of both sides. I get n plus 5 equals plus or minus 10. 100 is a perfect square. And then to solve for n, finally, I'm going to subtract 5 from both sides. And I get n equals plus or minus 10 minus 5. And don't stop. I can actually do that. So 10 minus 5 is 5. And then negative 10 minus 5 is negative 15. Here's my two answers. Okay, number 19. Adding 30 to both sides to start. And I get p squared minus 16p, leave myself some space, equals 40, leaving space. Now I take my b value, which is negative 16, I divide it in half, and I get negative 8, then I have to square that to give me 64. This is what goes here and here now. So I'm adding 64 to both sides. Don't forget, you will always get a positive number when you square something, so you should never have minus in that blank. It should always be a plus something. My left side is going to turn into a binomial squared, and my right side becomes 104. Okay, so in green again, I'm going to circle what's in the parentheses. That's going to go right here. And then I also have that variable, which is p. I have p minus 8. Using my normal solving skills, I'm taking the square root of both sides. I get p minus 8 equals the square root of 104. Actually, I'm going to put that plus or minus right here. Plus or minus root 104. And I'm going to go ahead and break that down right now. Root 104 broken down, 2 times 52, 2 times 26, 2 times 13. These are all prime. So my root actually becomes 2 times 2 times 2 times 13. And then I'm going to circle my pairs. I just have one pair actually, just a pair of 2's. So this becomes 2 root 2 times 13, which is, oops, 26. There we go. All right, that's going to go here. So back to blue, I have p minus 8 equals plus or minus 2 root 26, but then I have to add 8 to get p by itself. So my final answer is p equals plus or minus 2 root 26. Why did I say 28? Sorry. Plus 8. You could also write it like this. 8 plus or minus 2 root 26. I actually prefer it this way. Just because sometimes if I write my radical, it becomes a little longer, and I don't want that plus 8 to be stuck under the radical. I want it to be out on the outside. You can write it either way. Okay, and then 20. Didn't leave myself very much room here. Okay. Subtracting 29 from both sides is always my first step, getting that c value over to the right. So I have x squared plus 4x, leaving some space, equals negative 29, leaving some space. Do not forget that if you're subtracting a number from 0, you get a negative. So don't add 29 to both sides. It's always going to be minus 29. All right, then I'm going to take my b value, which is 4, divide it in half, and then square it. So this goes here and here. My left side becomes a binomial squared, so something squared. And then on the right side, I get negative 25. Now don't forget, whatever's in the square root, or I'm sorry, whatever's in the parentheses goes here. So I get x plus 2 squared equals negative 25. Regular solving skills, taking the square root to get x plus 2 equals the square root of negative 25. And I'm going to do this quickly. Root 25 is just 5, but I have that negative in there also. So this actually becomes plus or minus 5i. Okay, so when I did root negative 25, I'm turning this into the root negative 1 times root 25. Root negative 1 is just I, and then the square root of 25 is 5. But I don't want to write it I5, I want to write it 5i. Treat it like a normal variable. You wouldn't say x2, you'd say 2x. Alright, and then subtracting 2 from both sides to get that x by itself. I get negative 2 plus or minus 5i. And I'm done. Okay. Last page, target 6, I can use factoring to solve a quadratic. I get, let's see, I have x squared minus 5x minus 24. I have no GCFs, so I'm just going to skip that step. And I'm going to think of what times what is going to give me negative 24, but also add to give me negative 5. So off to the side here, I'm going to write out the factors of negative 24. I have 1 and 24, one of those would be negative. I have 6 and 4, one of those would be negative. I have 2 and 12, one of those would be negative. And then I have 8 and 3, one of those would be negative. And I'm saying one of those would be negative because if I multiply 6 times 4, that gives me a positive 24. But if I multiply negative 6 times positive 4, I will get negative 24, and so on and so forth. So one of those will always have to be negative if I'm looking for a negative. I noticed right off the bat that 8 and 3, the difference between those numbers is 5. So if I'm looking for a negative 5, I can just do 3 minus 8. So 3 is positive and 8 is my negative number. Whoops, drop the marker. So negative 8 times 3 will give me negative 24, and then negative 8 plus 3 will give me negative 5. So what I'm going to do next is take this, and just all I'm doing is breaking up my b term into two things, negative 8x and then positive 3x. So I can rewrite what I was given in the beginning as x squared minus 8x plus 3x minus 24 equals 0. Okay, so now I'm going to go ahead and use my grouping strategy and factor out GCFs from both of those groups. I can factor out an x from here, and I'll be left with x minus 8. And then from that second grouping, I can factor out a positive 3, and I'm left with x minus 8. And my whole goal is to get these two factors to be the same. So now my actual final answer is x plus 3 times x minus 8 equals 0. I pulled these two together to make this, and then I pulled these two together to make this. I'm not actually done. I have to solve here, and I didn't leave myself with a lot of room, but that's okay. I have to do x plus 3 equals 0. When I subtract over 3, I get x equals negative 3. And then I have to do x minus 8 equals 0. When I add 8 to both sides, I get x equals positive 8. So negative 3 and positive 8 are my answers. Sorry, I kind of did it off to the side there. All right, smaller next time. All right. Number 22. I don't have a C value in this case, which means all I'm going to do is factor out a GCF. That's all I can do. And in this case, I can actually factor out a 3n. So I can divide, let me start over. I can divide both of these by a 3n. So I'm taking 3n, pulling it out front, and what I'm left with here is, oh, just kidding, I can actually divide both those by a 6n. I'm left with, oops, my goodness, what am I doing? Sorry. Okay, so I'm pulling out my 6n, it was my GCF, and what I'm left with is 3n plus 2 equals 0. So I'm solving. So now I'm done. All I have to do is set both of those factors equal to 0 and get an answer. So 6n equals 0. To get n by itself, I'm just going to divide by 6, and I get n equals 0. And then 3n plus 2 equals 0. When I subtract 2 from both sides, I get 3n equals negative 2. Then I divide by 3. And I get n equals negative 2/3. So here are my two answers. Okay. Number 23. I have 5x squared plus x minus 4. I don't have a GCF that I can pull out, but what I'm going to do is say what times what is going to give me a times c, in this case is negative 20, and then what plus what will give me 1. All right, so the factors of 20, negative 20 off to the right, 1 and 20, 2 and 10, 5 and 4, 5 and 4. And I need my answer when I add them together to be 1, so I'm going to say 5 minus 4. So my 5 is positive and my 4 is negative. So a 5 and a negative 4, and then a 5 and a negative 4. So what I'm going to do is rewrite my quadratic with these two broken up. So I have 5x squared plus 5x minus 4x minus 4 equals 0. Grouping first two and last two, I can pull out a 5x. I'm left with x plus 1, and then I can pull out a negative 4, and I'm left with x plus 1. So now my real answer, my factored version, is 5x minus 4 times x plus 1 equals 0. Now I still have to solve here. So 5x minus 4 equals 0. When I add 4 to both sides, I get 5x equals 4. And then when I divide both sides by 5, I get x equals 4 over 5. And then x plus 1 equals 0. When I subtract 1 over, I get x equals negative 1. All right, and then finally, 10n squared minus 52n plus 10. I'm going to go ahead and pull out a GCF of 2. I'm left with 5n squared minus 26n plus 5. So I'm looking for two numbers multiplied together to give me a times c, which is now 25. My new a is 5, my new b is negative 26, and my new c is 5. And then what adds together to give me negative 26? Well, factors of 25, that will give me negative 26. I'm not even going to go any further here. 25 plus 1 will give me 26. Since I have to have a positive 25 when I multiply, I can make both of these negative. Negative 25 times negative 1 does give me positive 25. And then when I add them together, I get negative 26. So negative 25 and a negative 1 will give me my answer. So I can rewrite this. Keeping my 2 out front, I have 5n squared minus 25n minus n plus 5 equals 0. Then I can group, and I'm going to start using brackets here. So 2 bracket, what can I factor out of 5n squared minus 25n? I can pull out a 5n, and I'm left with n minus 5. And then what can I factor out of negative n plus 5 so that it turns into positive n minus 5? Well, that's just a negative 1. And I'm left with n minus 5. So now I have 2 times 5n minus 1 times n minus 5, and I am done. I just have to solve. So 5n minus 1 equals 0. When I add 1 to both sides, I get 5n equals 1. And then when I divide by 5, I get 1/5. and then n minus 5 equals 0. When I add 5 to both sides, I get n equals 5. All right. And then target 7, I can factor the difference of two squares with and without a greatest common factor. B squared minus 9. I have to ask myself 3 questions. Is there a b value? No. Are both those numbers perfect squares? Yes. Are they separated by a minus sign? Yes. That's going to be true in all 4 of these cases because actually it tells me I'm using difference of squares. So when you're doing these problems, ask yourself those 3 questions, but I'm only going to do it on number 25. So what I have to do first is take the square root of b squared and then take the square root of 9. Square root of b squared just gives me b, square root of 9 is 3. What I'm going to do with those 2 numbers, or those 2 values, I'm going to add them and subtract them. B plus 3, b minus 3. That is how easy, whoops, the difference of squares is. I'm not done, I have to solve, hang on. My bad, I got too carried away. So now I have b plus 3 equals 0, and then b minus 3 equals 0. I get b equals negative 3, and b equals positive 3. Number 26, same thing. Square root of b squared gives me b. Square root of 25 gives me 5. There's no b value. They are separated by a minus sign, and they are perfect squares. So same thing, adding them and subtracting them. I get b equals negative 5 and b equals positive 5 as my answers when I set both those equal to 0. Number 27, I can actually factor out a GCF here. It's going to be a 2, and I'm left with x squared minus 1. Now my new a value is 1. I don't have a b value. My new c value is 1. They are separated by a minus sign, and they're both perfect squares. The square root of x squared just gives me x, and then the square root of 1 is just 1. Don't overthink that. All right, so my 2 stays out front. I add those 2 numbers together, and then I subtract them. And now I have to solve. X plus 1 equals 0, and x minus 1 equals 0. I get x equals negative 1, and x equals positive 1. Number 28, I can factor out a GCF of 2 here. Nothing more, nothing less. 4 doesn't go into both of them, nothing else will. So factoring out a 2, I'll be left with 4x squared minus 9. And now I can take the square root of both of those. They are separated by a minus sign. They're both perfect squares. This is going to work perfectly. So the square root of 4x squared, I have to take the square root of both of those actually. So I get 2x as my answer. Square root of 4 is 2. Square root of x squared is x. And the square root of 9 is 3. So I take those, I add them, and I subtract them. Can't forget about my 2 up front. So I'm left with 2x plus 3, 2x minus 3. All right, now I just have to solve. 2x plus 3 equals 0, and 2x minus 3 equals 0. Using my basic solving skills here, divide by 2, and I get x equals 3 over 2. So I get positive 3 over 2 and negative 3 over 2. And that is the quiz review. If you're still having problems with any of the topics that we went over in this video, please go see one of the Algebra 2 teachers for extra help. You can fast forward through this video or go back to whatever you need to look at. The answer key is through the QR code, and yeah, happy studying.